tilbage til det tredje oplæg på Faglig Fredag, som bliver holdt af Erik Lund. Erik Lund, han er infrastrukturspecialist og har arbejdet og har arbejdet på rigtig mange projekter med stor succes, vil jeg nok sige. Jeg glæder mig meget til dit bud på en platform på bare metal. Så Erik?
Yeah, thank you. So, nice to see you all here today. When I saw the announcement of this day, I thought we need a third speech because now we got all these scary tellings, right? But how are we actually going to do this, right? So this presentation is about how you can actually move away from your hyperscalers and so on. So let's get started here. Yeah, as told before, my name is Erik Lund. I'm also known as Erik Lund&Bendsen because that was my old surname. My wife and I, we ditched that, so I'm just Erik Lund. Just if you know, I've been in this business for many years. I'm an independent consultant. I've been in that for many years. And I come from a developer background, really focused on making stuff better for the developers, because if you make it better for the developers, might be a chance that we get better results in the end for the applications and so on. So when I digged into Kubernetes in 2018, I thought this is going to change the world. So I digged into that and working on that ever since. So today we're also going to talk about Kubernetes as part of this. I have two kids, grown-up kids, and my wife as well. So today we're going to talk about the journey from a legacy world to something where you're running on cloud native at bare metal. So what is legacy world? Well, any big companies or any company, they have some kind of legacy. Even the startups, quite soon they get some legacy. That's probably why startups rewrite their code many times as they grow. So even a large pharmaceutical producer kind of stuff, moving to something you heard before, the Heimdall, they still have a lot of legacy around it. So let's go through the talk today. I will talk about typical layers and silos in data centers, and about declarative infrastructure. We'll go and look into virtual machines, how to take responsible for that, because normally when you talk Kubernetes, you don't talk about managing virtual machines. Then I will run some demos, a couple of those during the speech, and come up with some bare metal roadmap for you. And finally, some non-technical changes to your organization, stuff like that, and then let's have some Q&A in the end. So why are we all speaking about this cloud native? Why do we want to move away from our legacy that has been running for 20 years? Why should we move away from that? Well, we have all heard it today. Security, security, security. Everyone talks about it, the security part. But we also have to dig into reducing cost. We have seen that the interest rates goes up. That costs a lot of money for companies that has a large debt, and might need to reduce your cost. We also heard from the cloud FinOps. But also the reduce of login, and this is exactly what we heard just before in the other talk. We had a lot of vendor logins, and then what we're also seeing, third-party solutions, they come up and say, oh, well, from our next release, we will only run on Kubernetes. We don't want to manage installations on virtual machines and so on. And more companies, they see that. They bought some kind of systems. It could be payroll system, could be whatever. And now they have to run it on Kubernetes. Do we have someone from Danish radio broadcasting today? No. But this is a public company, so I can say it as it is. They have vendors saying, well, in your setup cars driving around, we have to run Kubernetes because our new software for broadcasting stuff is running on Kubernetes. So it's popping up all over this Kubernetes. We heard Siemens installing Kubernetes on their switches in their power windmills. So it's just popping up all over. And finally, getting ownership of your own technology stack. So get rid of this. This is also what Heimdall is about. Get ownership of your technology stack. When I talk bare metal, it doesn't have to be on-premise. So this presentation also covers when you run on other cloud providers, where you can get bare metal servers or dedicated servers, as they most likely are branded as. So remember that. Whenever I say your local data center, it might be somebody else. It might be some company that you work together with in Denmark, or a foreign company. So this journey I'm going to talk about today is from my experience from different companies, especially TDC-Net, who moved from a very, well, it's an old company, it's founded 1879 or something like that, so it has some legacy in it, right? But we managed to bring that into play running bare metal stuff that I'm going to talk about today. I also built this presentation on the shoulders of other giants, like Nokia has done this for several years. So it's not just me coming up with some random thoughts. So before we continue, how many of you know about Kubernetes? That is everyone, right? Maybe there's a single one that doesn't. I just had one slide in case we had someone that didn't really have that much into Kubernetes. But 4 lines is what I will say about Kubernetes. It's a resource model, which is kind of the core of why Kubernetes became this success. It's API driven, so it has CRUD methods for that. A lot of developers probably know about CRUD. And then it's extendable, so it has these custom resource definitions. So it's quite easy to define new objects. And then again, it has a pluggable architecture, plugging in different implementations, for instance, for the container runtime. So in other words, Kubernetes is giving us what we have asked for maybe 30 years. We can define new APIs, and we can easily do implementation of those APIs, and we can schedule them. Remember the old days about object-oriented stuff, components, want to do component-based development in the 90s? So now we got it. Now you can define your API, like here, we have a Redis cluster, blah, blah, blah. This is an API written as a YAML, and from that, we get a operator that reads this YAML and then spins up all the stuff you need. So this is not Terraform we're talking about here. This is not some stuff you have to run and go somewhere and do that. This will reconcile all the time. So if you change something in your YAML, it will change it in your infrastructure. So this is the reason why Kubernetes became such a success from my point of view. Of course, there's a lot of other stuff on that part. So when we talk the first generation of Kubernetes, and I go to companies and see when they run on-premise, they often end in a stack like this. They have some data center guys doing physical hardware. They have an infrastructure department doing hypervisors. It could be VMware. It could be other implementations. And they have some operating systems. Maybe they use Ansible and so on to set up these virtual machines. And the infrastructure department, they would like to know about these operating systems. They would like to install monitor tools, security tools, scanner tools, whatnot tools on these machines. And then we have the platform engineers. They want to install Kubernetes on these machines as well. So we get an overlap between the platform engineers wanting to run Kubernetes and the infrastructure running their legacy portfolio of stuff on these machines. So it gets a lot of muddy in this virtual machines. And of course, you could do something about that. You could let the platform engineers own the virtual machines. That means the infrastructure department can't log into those machines. They can't do any changes to it. This is where I introduced Talos, and this Talos is a immutable operating system. I'll come into details in a minute. But here we give the platform engineers an API for managing their operating system. So no more Ansible, no more whatever you Python, no more stuff that Yum or whatever you could do on your Linux machines. And infrastructure, they don't get any access to these, so they can't mess it up. They will keep the hypervisor like VMware and stuff like that. So if you dig into Talos, which is an operating system from Citadel Labs, it's an immutable operating system. That means you cannot go in and run some Yum commands and update RPM to update stuff. It is as it is. If you want to change anything, you have to make a new version of it and boot that up. It's only meant for Kubernetes, so it is a cut down version. There is no SSH. You can't do that into it. So imagine your Linux servers, but no SSH access. That's good because then we know the state of the server. The moment you let someone SSH into your server, you don't know the state of it anymore. People can do stuff, or scripts can do stuff, right? Pipelines can do stuff. So there's no access. Everything is by API and declarative. So Talos is not really a Linux distribution. It is just a Linux kernel, the Linux kernel, with the libraries and a few binaries. Some of them are containerd, runc, and VM, and so on. And they really keep these numbers down to less than 20. In the latest version, there's a bit more because of SE Linux and so on, but it's between 12 and 20 binaries on that machine. So compared to any of your other Linux distributions, even Flatcar, they are huge. But on the other hand, it can only run Kubernetes. So what if we got rid of these infrastructure people for managing the hypervisors, because we could run Talos directly on physical hardware, on bare metal, and thereby we would reduce the number of our silos even further, and we could have pure infrastructure as code or declarative infrastructure. But when we start the road of bare metal, we also inherit a lot of problems that were solved by the infrastructure team, by the hypervisor. Now we need to find out what happens when you boot a bare metal machine, a physical machine. Do we use iPXE for booting? Do we use Redfish? It's an API for talking to the small computer inside the big computer, where you can do management of the computer, turn it on, turn it off, boot it, and so on. But you can also give it an URL from where it should load the image to boot from. You could also, if you're really hackathon Linux expert, you could go in and use KExe, which loads a new kernel, and then you could give control to this new kernel. You all have tried running Linux in memory only, right? It's not persistent anyway. This is how it actually does. You load a new kernel. So the first two of those are mostly for running on-premise, but if you get into a cloud provider, you might not be able to use iPXE or Redfish. Then you can use this one, just boot any Linux, and then go in and install these KExe tools, and then you can change the kernel and get it written to disk and so on. The next time you boot, you are on Talos. So you need to look into how do we actually fix this. And same with the Talos configuration. You can choose to push it to the servers or pull it, depending on do these servers know where to pull the information, or will be some management that just picks some servers by maybe MAC addresses and so on and pushes the configurations to those. We should also think about how we actually provision these bare metal servers. There are a lot of different ways of doing it. We have Citadel Labs that have their own enterprise version called Omni, where you can boot up some machines, you can join them to clusters and so on, remove them from clusters. You also have cluster API from Kubernetes. And there's also one called Cozy Stack. It's a company that tries to make it very easy to build bare metal machinery, Kubernetes on bare metal, and give you some virtualization on top, virtual machines on top. But anyhow, whatever you choose, you must make sure that you establish some kind of root of trust. How do you actually trust this hardware to join your cluster? When you're a developer, you don't think much about that. And when you have infrastructure people running VMware, for instance, they will fix that. They know they bought this super expensive machine, right? They mounted it, and they put it into the ESXi, installed that, and so on. But what if you go into commodity hardware, much cheaper, and you just have racks, rooms with racks? How do you make sure that nobody just plops in a Raspberry Pi and try to join your clusters and so on? So I think we should have a small demo, because we haven't had demos today. And yeah, we should have demos. What I did, I probably have a slide more. Yeah, I'll show you some more in a minute.
Can you change to white background? It's much better on the projector.
To white background? Yeah, but I could also just zoom a little bit like this. Is it okay? Because now, or yeah, I could go and try to do that, but I'm in full screen now, and probably a lot of stuff will. Unless somebody knows a shortcut for toggling. I could ask. Well, time is running. No time for this. So what I want to do is I run a command for initializing a server on Hetzner. I give it a server ID and then a disk where to install this Talos. And then, because I want to cut down the demo to shortest viable solution, then we skip going into rescue mode, because that takes some time to do. And what I use is this tool I wrote at some point that makes it very easy to create or install Talos on Hetzner dedicated servers. There are other tools for doing it as well, but a lot of people want to get starting on Talos and they don't really have the hardware for it. So I wrote this utility so it makes it easy to start. And Hetzner servers are so cheap. If you go into their auctions, you can get one for maybe I shouldn't do commercials here, but let's say around less than 40 euros for a month, which is kind of cheap, much cheaper than AWS and so on. But we have this tool here, and some from my Git page on that. So the demo here, I'm running this init command, and it installs this proprietary, or uses proprietary API towards Hetzner to install the stuff. And then we can ask for health, and then we can apply the Talos configuration to the server. I've generated that before this demo. Then we will bootstrap the server with etcd. We have to do that the very first time we create a cluster. For the first node, we need to bootstrap and say this is actually a node that shouldn't join other nodes, but it should be the first one. So let's see if we got somewhere here. We didn't go there.
VS Code is Control KT.
Control. Yeah. Is it completely invisible? Okay. So let's see here. Let's take a health. So now we can see we got a connection, but it said this certificate is not correct. And that's because we haven't really pushed any configuration to it yet. So let's take and apply our configuration to it. So the YAML file is, well, it contains some secrets I don't want to reveal right now while I'm running this. If some live hackers want to join some stuff. But here is a subset of it, where it shows disks, images, and so on, the network, how it's configured. It's of course much longer, and you can define everything that you normally define in Ansible when setting up a Kubernetes cluster or kubespray or cluster API. So let's see here. Let's take a bootstrap of the first node. Okay. Let's see how far we actually got on it. See if the dashboard is here. Yeah. Make it a bit larger. Like this. So this is a dashboard of Talos. We can see that now it's not really in ready state yet. It's still printing out some stuff. The kubelet has started up, and so on. If I just zoom a little bit, I can see the API server is not available yet, but it will come soon. Okay. So now I actually got a Kubernetes cluster running live. And if we go back to the presentation, we can see here I did the dashboard. I could go and get nodes and pods and so on from this cluster. I just showed you a small snippet of the configuration, but you also have these machine configurations. This is not a Talos talk, so I'll not go into those details. So what we just brought up before was a machine, bare metal machine, running in Finland, because it's better CO2-wise than in Frankfurt, and it's running in my Kubernetes cluster. But what does this give us? Yes, it actually gives us that we can run Talos in Talos. We can create Kubernetes clusters inside this Kubernetes cluster. That means if we install KubeVirt, do you all know KubeVirt or heard about it? KubeVirt, yeah, we'll dig into that in a minute as well. The idea is that you actually can run virtual machines like it was pods in your Kubernetes cluster. You can't do that if you run on VMware, for instance, because then you'll get too many nested layers of virtualization. But when you run on bare metal, you can do that. That means the platform engineers now own the complete platform for running Kubernetes on bare metal, the KubeVirt, all the nested virtual machines, which could be Talos VMs, it could also be Windows machines, could be other stuff running in that. They own that, and they have a same API for everything, the Kubernetes API. And they don't have to go to the other silos, don't have to change to another API, which is proprietary, seen from Kubernetes. So let's dig into KubeVirt. KubeVirt is an old technology, almost 10 years old, built by Red Hat, and it's built on KVM, which is a part of the Linux kernel. So this is where you can do virtualization in Linux. So if you talk to some of these cloud providers, they probably want some kind of KVM at the bottom to do the virtualization. So whenever people come and say, we cannot run your stuff because our third party says it's only certified for VMware, and then you can ask them, are you sure it's not certified for KVM as well? And then they'll come back and say, oh yeah, of course it's also certified for KVM because this is most used virtualization technology in the world. So don't be scared about that. On top of that, we have the container runtime and Kubernetes and so on, and then KubeVirt is running on top of that, managing these. Let's see here. We have a YAML. Again, it's on a black screen. It's a bit weird because most presentations nowadays are done on monitors, so I changed everything to black to be to match that. So anyhow, I hope you can read it. This is a virtual machine. It's a definition of it. It's built on the CRD. You can see at the top, KubeVirt, and with the kind virtual machine, and then I define what I want. Of course, this can be much longer with a lot of more details in it. Next demo, we will try to run a virtual machine on one of these bare metal machines at Hens. So we will apply the configuration for it. I'm not using Argo CD and all the other stuff we normally do, because this is a demo, right? We just want to have some quick feedback here. So let's see. Let's get what's the events on this Kubernetes cluster, and maybe I should bring my glasses to see if it runs. And we could also go and check the dashboard for it. It's healthy and so on. Sorry. And then let's go and apply this virtual machine to it. And you can see the events are popping up. It's now creating a lot of stuff behind the scene to create this virtual machine. And just see if we should go and then we can see the status of it. We can see the virtual machine and the virtual machine instance of it. And let's go back here and see if we can do that. Yeah, well, it's probably not ready yet. We can see it's still starting. And then we can see it's here. Now it's scheduling and starting up. And we can then try to do a SSH into this virtual machine, because this is, of course, an insecure virtual machine running SSH. How could I do that? But, well, there are still some tenants that want to run virtual machines, which are not ready to migrate to containers and so on. So let's see if we get a, we can do a port forward to it. I didn't want to expose this virtual machines to the internet. We're not really sure it's secure. So I'm just doing a port forward to it, opening a channel through Kubernetes to this port where the virtual machine is running. And then we can do a SSH into it. Yes. And just to show that this is actually a virtual machine and not just another pod, you will see all these nice processes running inside your Kubernetes cluster, right? So now we can offer running Windows, Linux on Kubernetes in virtual machines. But why? Because of security, because of the pay cost we have to pay our hypervisors for running their hypervisors, right? Why should we pay a huge amount of money for something that we really don't need nowadays, that we can do with open source? Yeah? I can say it again. Yeah, I could.
Ja, betyder det så i praksis, at man sådan ligesom testpatcher sine noder, inden man applier en ny version, for eksempel?
Yeah, you would go through different staging environments where you test this, and you can also just apply it to a single machine, see how it goes before you apply it to the other. Talos has very easy means for upgrading Kubernetes, and also the Talos operating system, so you can do it in one command. And other reasons for doing this could be, maybe I have it on slide actually. Yeah, I think I have it on slide. I really like people when they come with the question, and then I have the answers just on the coming slides. So, just as we talked about earlier today, Active Directory, for instance, if you have identities, you might still have some coupling to that, that you are forced to use that. Yeah, so why would you run on bare metal, right? Why would you do that? I really thank you for the question. Now I'm typing the answer here. So you can't do virtualization. Your default run virtualization on these hypervisors. That means you cannot spin up virtual machines inside Kubernetes, for instance. If you look at Azure or AWS, you can spin up a virtual machine outside of your Kubernetes cluster, but with references to your Kubernetes cluster and so on. But those are often specific for that vendor, how that is done. Then you get these external dependencies with the silos we talked about, the login, the high licenses cost, and so on. And the multiple APIs. You have to know the APIs for your hypervisor. You have to know it for the Kubernetes, maybe even some hardware if you want to shut down some machinery and so on. So a lot of different APIs. And each of those hypervisors, they try to come up with their own language, like Bicep from Azure, or whatever it's called for VMware. They have multiple versions they try to do. But they all have that kind of say, we want to have the whole world. But instead focus on Kubernetes, which are open APIs. Of course, you also get something from using a hypervisor. You get this storage, for instance, if you have some network storage and so on. And you don't have to know about hardware, right, as a platform engineer. But on the other hand, when you run Kubernetes on bare metal, yes, you can't just blame others for stuff not working. You can't say, it's infrastructure, right? Right? You own the problem now. You have to fix it yourself. And of course, you're not throwing out the infrastructure people. You are taking them into your sphere and training them on the new stuff, because I actually know a lot, those infrastructure people. And of course, the storage solution, you need to find somewhere to do your storage in Kubernetes, outside Kubernetes, or special Kubernetes clusters with optimized for storage, running on servers optimized for storage, and so on. But as I said it before, you really get a lot of pros, a lot of positive stuff. The one API for everything, much easier to automate the full stack. You get less dependencies, and you can use these resources much better. Right? If you get a bare metal machine running on local NVMe disks, you get a complete different result of I/O and throughput of that. So if you're running your logging solution on VMware or some other stuff, it's really draining the vSAN and so on for resources, right? It's very expensive to do that. Is that a question? Yeah?
The slide you showed the other time where you would put a talus upon a talus, could that mitigate some of the cons of Kubernetes on bare metal? Like you could have the base layer, you would have some silo guys that you could not blame but could help you kind of...
Yeah, you use the same technology, right? So it's easier. Everything is declarative. You can use GitOps and Argo CD or Flux for it all. You could, of course, treat your bare metal servers a bit different than others. I work with the companies where we've got a lot of tenants. Tenants could be projects, developer teams, and so on, but it could also be other companies. If they want a bare metal cluster, they can get that, right? But maybe they just want a test cluster, so they can run a nested cluster on top of these. So maybe you have your bare metal cluster as a production cluster, but it's not maybe running production nodes as you normally would. It's running other test clusters and UAT clusters, whatever clusters you want to spin up. Some of them live for a day, some of them for hours, or maybe some will last forever, right? Almost. Yeah.
Thank you.
One example was a vendor that came in with a solution. They wanted to run some databases, and that version they were having right now, the database had to run in virtual machines. A lot of sharding, a lot of virtual machines, right, for these massive amounts of data. So they were really not ready to run on Kubernetes for everything. So we could just spin up some virtual machines, and those could run these databases using the local NVMEs on these bare metal machines, right? So we got super fast response time, and of course the replication is done now in the database layer and not at the disk layer instead, like a vSAN would do. Yes?
Yeah, I have a little question for understanding this. So the bare metal, that means we are running on a private machine. There's nobody else but this one running, right?
Yes.
Yeah, and if that was a Raspberry Pi, that makes very much sense that because the Raspberry Pi is a physical machine you have in your IoT network somewhere. So that means we will be able to run Kubernetes on all these guys with this system here.
Yes, yes. The virtualization will of course require that the CPU supports virtualization. And it also requires that it has CPU power enough to do it, right? If you run a Raspberry Pi, a very small version of it, you'll probably get some performance issues doing that.
Yeah.
Right? But you can use the Talos part of the Kubernetes, so you can install Kubernetes on your Raspberry Pi easily.
Yes, and the second question, understanding question, was the reason for running bare metal is that when you have decided to run Kubernetes all together, then it doesn't really mean anything to have a hypervisor.
Yeah, you can say the hypervisor is now Kubernetes instead.
Yeah, exactly.
Right. So
Thanks.
Yeah. Other questions? Or?
Yeah, I think one of the questions in my mind is like the cons here is storage solutions must be handled.
Yes.
And I don't know, just to think about the consequences of that statement, it feels like then you're saying the only thing the hypervisor used to do is handle storage solutions.
Nah, it's because they handle it so well. So this is it's probably what they are very best at. If you look at the hypervisors, it is I/O and storage, right? So.
But the OS layer it does a lot of things. Are all these things now in this tiny Linux distribution?
No, it's in the Kubernetes. So you move a lot of stuff from being processes running to containers running. So you containerize your operating system, you can say. So instead of you have a virus scanner running or stuff like that as a process in the bare metal machine, you now have a pod that monitors stuff in Kubernetes, right? Do vulnerability scanning and stuff like that. Yes. So it's really you have to talk to these infrastructure guys because they're not used to put their stuff. They're used to run stuff on virtual machines that runs as root, doing monitoring, SolarWinds, backdoors. And we don't want all these backdoors into the system, right? We don't want people running as root and have remote access to our servers. So again, talking about security, we don't trust nobody. So don't let somebody run as root on your Linux machines, right? On your hypervisors, whatever base machines you have. So time is also running. Let's see. So on top, this is actually a bit following what you're saying. We have some capabilities we need to solve, the networking, the storage, and so on. And we do all that in the Kubernetes world, the vulnerability management, the observability, disaster recovery and backup. All that is done by Kubernetes. You can get free open source software for all of that. You could also pay for some of it and contribute to the open source communities. And then you get the physical world, which is probably new to most of you, where we have physical machines, you have physical networks and connectors, power, the DC of that, and so on. And remember, if you don't have a server room already, look at access to it, security as a physical access to it, and also environmental safety of it. We don't want anyone to get DC power through their body, right? We talk a lot of power in these racks. And of course, facility management, the buildings, the temperature, humidity, all that kind of stuff. So please reuse your existing people that knows about it. And if you're completely blank, not having any resources for that, you could team up with another company that knows something about it, maybe even running on their locations instead. This is what we did with Hetzner in this case. Hetzner was just used for the demo. Could be a lot of other providers instead. So this hardware. This is a random picture from the internet. And I put a X on the console because I don't want this console. This console is the disaster recovery kind of stuff where you can't do anything else. You have to go there and do something, right? You want APIs to manage your hardware. So don't buy the hardware that doesn't have baseboard management controllers, right? You have to buy those kind of enterprise server, enterprise data center servers with a BMC, because then you can turn on and off the servers from an API. Because it doesn't really matter if you scale down all your Kubernetes clusters if you don't shut down some of your physical machines, right? So imagine you're running VMware and you're shutting down your clusters at night, but VMware people, infrastructure, they do nothing. They don't shut down a complete EXI host to save some power and move all the virtual machines around, right? And you're not getting the API for doing it either, right? Because you not get access to that because they own that API. But here on the Kubernetes stack, and you have these APIs, you can actually do it using, for instance, the Redfish API or protocol, iDRAC from Dell or ILO from HP and so on. You also need a database that covers all of this. So put it in a CMDB so you know where everything is. And of course, you want to monitor your hardware, so you get into Prometheus and so on. So when we talk about getting this hardware, well, you have to establish and get the right hardware. And you really need to talk to somebody knowing your data center, because you need to find the right transceivers, the right cables, and so on. And you need to find out where to place your hardware. You need to make sure there's room for expansion. And the FinOps make sure that you also have money for mounting the racks and not just buying the equipment and so on. And again, networking, suddenly we used to cloud where you just get network, right? But here you also talk about physical network. You need to know the wiring of how you do your racks. Do you have a top of rack switch and so on? A lot of stuff here. Also kind of do your network hardware support XDP, which is making it super fast and stuff like that. If you run Cilium, which is, I guess, the new standard for running network in Kubernetes, all the network providers, all the big cloud providers, they are now running Cilium because it has this eBPF, and all the Linux people that knows eBPF will just say, yes! I don't know how many said that here in this, but this is super, super, super cool. It's read about it one day. It helps you with security, performance, a lot of stuff. But it's another talk, another day. And so that was a lot about stuff you need to go into that you're not used to work with, right? But you also need to change your organization, maybe. The mindset of people, the way of working, the procedures for approving changes to production. Everything now becomes infrastructure as code or declarative. So you can use Git, merge request, or pull request for approvals and so on. It's very hard to do this bottom up, sitting in a corner and starting doing this. You need to talk to management and get them aligned high in the organization, so you get a cross-organization compliance on this, right? I think this is the most important to do. All the stuff I did when I went to companies changing stuff, we just, two companies, we went to the board to get it approved, and when the board approves, well, then you can go, right? So that's really my recommendation on that. And again, the developers, they also need to know about this pipelines and all that kind of stuff. It's another talk on that. And finally, if you don't want to run on your own servers right now, you could start up on some European companies. This is just some of them out there. And you will see more and more popping up, stuff like Lidl Cloud is another actor on this. I'm pushing a little bit for the big companies in Denmark to start building this, and then when they get it mature, do it as public stuff, so they could run on my company cloud, right? Why is only a bookstore in US able to run a cloud? So that is it. Time for questions and hopefully answers. Wasn't that on time? Yeah.
I have a question. How about licensing? Because this Tell us, is that open source?
Yes,
Oh.
it's open sourced, and it's made that way that if somebody buys the company and tries to change that, then it pops out and becomes independent. So it's not like Oracle can go in and buy them and then start putting licenses on it, then it will forego to a open source stuff.
Yeah.
Of course, you can pay for support if you want that, and do a support agreement with them.
So if one of your KubeVirt machines requires access to hardware, I/O, MMU stuff, for example, a AI co-processor, something, is that possible?
Yes. With Kubernetes, you can do that. I already get access to GPUs and so on. And with Talos, it's super easy. When you build your image, you just say, I want this extension for GPU from NVIDIA and so on. I want this extension for Intel CPUs. You get that. So you easily get that into it. You can also build your own extensions for that as well.
Yeah, sure. But also when you, there's more a comment actually. If you choose to build it with Cluster API and you're afraid of Talos, you have an easy mitigation policy, because Cluster API also comes with a side project where you use, it's called Image Builder, where you can pretty much pick any Linux distribution and replace that with on your bare metal machines. So like it's not vendor login, it's technology login, I would say. And also a side note on KubeVirt is that Red Hat is actually implementing this to get rid of OpenStack. So all of the features that is currently in OpenStack is something that they're planning on at least supporting with KubeVirt. So it's also for the maturity. And I was recently at KubeCon where they were talking specifically about like the performance penalty of running VMs in containers, and there was none.
Yeah, so Red Hat had a full day talk about this subject last week. They of course also want to get a share of this hypervisor market, so you can of course also talk to them about it. You can actually run OpenStack on top of Kubernetes. So Nokia, who is doing a lot of this, they are right now working on that part. Maybe I had it in my slide. I skipped probably talking about it, but Nokia is doing a setup where they move that and then slowly migrate away from OpenStack to Kubernetes. So flipping the stack, as I say in my talks, we are turning all upside down. We're putting Kubernetes at the bottom, and then we put stuff on top that used to be below.
Okay, thank you, Erik. So